Every single year, without exception, there is a moment in the meteorological calendar that separates the people who understand what spring actually is from the people who only understand what spring feels like. The people who only understand what spring feels like look outside, see the flowers blooming and the temperatures climbing, and they relax. They put away the winter gear. They stop watching the forecast. They assume the worst is behind them. And every single year, without exception, that assumption gets shattered because the people who understand what spring actually is know something the others do not. They know that spring is not a season of gentle warming and gradual calm. Spring is the most atmospherically violent season on the entire calendar. Spring is the season where the coldest air masses on the planet and the warmest, most moisture-laden air masses on the planet exist simultaneously, separated by nothing more than a boundary that shifts daily, sometimes hourly, and that produces the most destructive weather phenomena that nature is capable of generating when those two worlds collide. Spring is tornado season. Spring is flood season. Spring is the season of deadly hail, of killer ice storms, of nor'easters that bury cities in April snow that nobody saw coming because everyone had already decided winter was over. And right now, as I record this forecast, the atmospheric pattern across the northern hemisphere is constructing what I can only describe as one of the scariest spring weather setups I have analyzed in years. What is coming over the next 10 to 14 days is not a single storm. It is not one bad weather day followed by a return to sunshine. It is a sustained, multi-phase atmospheric assault driven by the fundamental mechanics of a spring atmosphere that has loaded itself to historic levels. And I need every person watching this to understand exactly what that means before it arrives. Let me start with the basic science, because understanding the fundamentals of why spring weather is so dangerous is the foundation for everything else I'm going to tell you. The entire engine of severe spring weather runs on one thing: temperature contrast. During winter, the cold air dominates and the atmosphere, while sometimes violent, is relatively homogeneous. During summer, the warm air dominates and the severe weather, while sometimes intense, is driven primarily by instability alone. But spring is the transition season, and during that transition, you have genuinely Arctic air masses, air that originated over the frozen tundra of northern Canada, Siberia, and Greenland, sitting within a few hundred miles of genuinely tropical air masses loaded with Gulf of Mexico and Atlantic moisture that is running 15 to 20 degrees warmer than the cold air to the north. That temperature contrast, expressed in meteorological terms as a sharp baroclinic gradient, is the raw fuel for every dangerous weather system spring produces. Tornadoes require it, severe thunderstorms require it, rapid cyclogenesis, the explosive deepening of low pressure systems that produces damaging winds and extreme precipitation, requires it. The sharper and more extreme that temperature contrast, the more violent the resulting weather. And right now, the temperature contrast across the northern hemisphere is running at levels that are genuinely extraordinary for this point in the spring calendar. Here is why. The polar vortex, the large-scale circulation of cold air that spins around the Arctic during winter and gradually weakens through spring, has undergone what meteorologists call a sudden stratospheric warming event over the past several weeks. A sudden stratospheric warming event is exactly what it sounds like: an abrupt and dramatic rise in temperatures in the stratosphere, roughly 30 kilometers above the surface, that disrupts the polar vortex and sends fragments of cold Arctic air spilling southward into the mid-latitudes at a time when those mid-latitudes are already warming rapidly toward summer. The result of a sudden stratospheric warming event on the surface weather pattern is almost always the same: an extended period of highly amplified, the atmosphere is telling us right now across Oklahoma, Kansas, northern Texas, Missouri, Arkansas, western Tennessee, and into Mississippi and Alabama. The window of peak tornado risk begins in approximately 48 hours, and it extends for at least 4 to 5 days as successive disturbances ride along the same jet stream track. This is not a one-day event. This is a multi-day, multi-round severe weather siege, and every community in that corridor needs to be treating it that way. I want to talk specifically about what makes spring tornadoes different from the tornadoes that occur at other times of year, because this is a piece of meteorological reality that does not get communicated clearly enough. Spring tornadoes are on average stronger, longer tracked, and wider than tornadoes at other times of year. The reason goes back to the temperature contrast I described earlier. The wind shear available in the spring atmosphere, the change in wind speed and direction with height that is responsible for the rotation in supercell thunderstorms, is dramatically greater in spring than in summer because the jet stream is still strong and still positioned favorably over the continent during April and May. Strong wind shear produces supercells. Strong, long-duration supercells produce long-track tornadoes. Long-track tornadoes that stay on the ground for 50, 80, 100 miles or more are the events that devastate communities rather than individual structures. They are the events that go down in history. And the wind shear values I am currently seeing in the model data for the peak period of this outbreak are among the strongest I have observed for any spring event in recent years. The potential for violent long-track tornadoes during the peak of this pattern is real and it is serious. The flooding threat from this spring pattern is the second catastrophic hazard, and in some ways it is more broadly dangerous than the tornado threat because it affects a far larger geographic area and it builds gradually in ways that lead people to underestimate it until it is too late to act. The combination of anomalously high atmospheric moisture content rapidly saturating soils across the central and eastern United States, and a series of slow-moving frontal systems that are going to stall and train over the same river basins for extended periods is setting up a major river flooding event across the Mississippi River Valley and its tributaries. When meteorologists talk about training thunderstorms or training rain bands, systems that move along a line and continuously deposit rainfall over the same location like rail cars passing a fixed point on a track. They are describing one of the most efficient and most dangerous rainfall mechanisms in the atmosphere. The pattern over the next 7 to 10 days is going to produce exactly this scenario across portions of the Mid-South and Lower Ohio Valley. Rainfall totals of 8 to 14 inches over 5 to 7 days across river basins that are already running above normal from earlier spring precipitation is a formula for flooding that goes well beyond the capacity of normal flood control infrastructure. Major and record flooding on the lower Mississippi, the Arkansas, the Cumberland, and the Tennessee rivers is not a worst case scenario in this pattern. It is a central case scenario that the model guidance has been consistent on for the past 72 hours. I need you to hear something about river flooding that people consistently underestimate until they experience it personally. River floods are slow, they give you time, but that time is only useful if you use it to act, not to watch and wait. The moment a watch or warning is issued for flooding in your river valley, your decision-making window is open. That window closes when the water reaches your road. At that point, you are no longer making a preparation decision, you are making a survival decision. And survival decisions made in moving floodwater, in a car, on foot, in a structure being inundated, have a dramatic. Across South and East Asia, the spring transition is delivering its own version of atmospheric violence, driven by the same planetary scale disruption, but expressing itself through the mechanisms that dominate weather in that part of the world. The monsoon trough across South Asia is activating earlier than normal this year, drawing anomalously moist Bay of Bengal air northward into the Indian subcontinent at a time when the heat of pre-monsoon season is already building intense instability over land. The result is a severe thunderstorm and hail outbreak pattern across northern India, Bangladesh, and Nepal that has been producing deadly events on an almost daily basis over the past 2 weeks. Hailstones the size of golf balls and larger have been reported from multiple storms across Uttar Pradesh, Bihar, and West Bengal. Flash flooding from intense convective rainfall is occurring across the foothills of the Himalayas, where the terrain amplifies rainfall rates dramatically. And a deep western disturbance, the extratropical system that brings winter and spring precipitation to the northwestern subcontinent, is positioned to interact with the early monsoon moisture in a configuration that could produce an extreme precipitation event across Pakistan, northern India, and the Himalayan foothills within the next 72 to 96 hours. I want to come back now to North America and talk about one more element of this spring pattern that does not get enough attention in standard weather forecasts: the late season winter storm threat embedded within the cold air component of this setup. Every year, spring produces at least one major snowstorm that catches communities off guard because the calendar says April and people have mentally filed winter away. This year, the cold air associated with the stratospheric warming event is deep enough and persistent enough that the late season winter storm threat is genuinely significant across the northern tier of the country. The setup I am watching for the late portion of this 10-day period has the potential to produce a major snowstorm across the northern plains, the Great Lakes region, and potentially into New England. Snow totals in the highest likelihood accumulation zones could reach 12 to 24 inches in a 24 to 36 hour period in April, after communities have removed their salt stockpiles, reassigned their plow crews, and mentally and operationally closed the chapter on winter. The late season storm is often the most disruptive precisely because nobody is ready for it. And I want every person in the northern tier of the country watching this forecast to understand that winter is not finished with you yet. This is the moment in this forecast where I need to talk directly and urgently about something that matters more during a multi-threat, multi-day, multi-region spring pattern than it does during almost any other weather scenario: your ability to receive life-saving warnings at any hour of the day or night. Spring severe weather does not operate on a convenient schedule. Tornadoes develop at 3 in the morning. Flash floods rise while you are asleep. The overnight hours are when the warning system fails most people, not because the warnings are not issued, but because people are asleep and their phones never wake them. This is precisely the problem that Max Alert exists to solve, and during a pattern like the one we are currently tracking, one that is going to produce tornado threats, flood threats, and severe weather hazards across multiple rounds over 10 or more days, many of them during overnight hours, having Max Alert active on your phone